Imagine this situation. You have several points, and you want to find a polynomial that fits them. For answering this question, we need to know the degree of the polynomial. Intuitively, you'd think that the more points, the higher the degree needed. But why would we need a high-degree polynomial? We can have an infinite number of points in a straight line, aka polynomial of degree 1 or even 0. The thing is, we will have to increase the degree if the points weren't in a straight line. And if you paid attention, we increased it by 1 in this case. Remember this point. Let's start with 1 point. We could pass an endless number of lines through it. So a constant function, aka a polynomial of degree 0, would do. If we add 1 point, we'll be restricted to a degree of at least 1 if the points don't have the same y coordinates. Now things get interesting. Each new point we add, assuming it's not aligned with the others, may force us to increase the degree by 1. Here we recognize the pattern. And guess what? It's correct. But that's not how math works. We need a reason for why this is happening, even if it makes sense. So we need to look at what makes more points sometimes require a higher degree. As we've seen before, adding 1 point requires increasing the degree if the points are making a curve. Neither 1 point nor 2 requires a curve to go through them. A straight line is enough. We need a third one to be the turn of the curve. In fact, any point inside can be the turn of a curve except for the edge points. So we know now that the number of the turning points is at max the number of the points minus 2. Now, what we need to do is to know what a curve means to a polynomial. If you look closely, it's the point where the function switches from increasing to decreasing, or the opposite. That's the only way it can turn. It can't go right to left or left to right, because then one x would have two y's, which is against the rules of the polynomial and functions in general. And the function changes direction means its derivative changes sign. And since it's a polynomial, its derivative is continuous. So for it to change sign, it must cross 0 at some point, and its derivative is another polynomial of a degree less by 1, which we know can't be 0 more than its degree. So a polynomial changes direction at max its degree minus 1 times. So if you have n points, you know that they will make at most n minus 2 curves. And a polynomial can make at most its degree minus 1 curves. A bit of algebra gives us d minus 1 equals n minus 2, means d equals n minus 1. So to conclude, if you have n points, if there is a polynomial that can go through them all, a degree of n minus 1 is enough.